Hey, what's up, fourth grade? This is Mr. C. So I promised you guys that I would do this experiment for everybody. I've done this with 2 classes, and I didn't want to leave the rest of the 4th grade out. And there are some students in, I believe, Miss Brown's class that didn't get to see this that want to see it. So we're going to do it right now. So let's talk about our materials first, and then I'll tell you what the experiment is. We'll do the experiment, and then we'll talk about what's happening. First thing is you're going to need a plate. I have a glass plate. I would recommend glass or porcelain, kind of a non-porous, meaning like not paper. Plastic would be okay, but if you can do porcelain or glass would be great. You're gonna need an empty glass. I'm using a mason jar. You don't have to use that. You'll need a coin. You'll need a candle. So I'm using one of these votive candles. You can also use tea lights. Basically, you want it to be able to fit inside the glass. You're gonna need some water, so I dyed mine blue just so you could see the water. And you're gonna need a lighter. The lighter is to obviously light the candle. Okay, once you have all those materials, let's go ahead and zoom in and take a look at what we're doing. All right, 4th graders, so I have my experiment set up here. So I have the plate, and so what we're gonna do is I'm gonna put my penny, I'm gonna put it on the edge. You don't want it up here, you want it so it's flat, okay? And then the riddle or the puzzle is, I'm going to dump a little bit of the water just so it covers the penny, right? You don't need a ton of water, about that much. I think that's good, just like that, okay? And the riddle here is, can you get the penny out without getting your finger wet, using only these materials, right? You can only use the glass, you can only use the candle, you can only use the lighter, okay? So can you get the penny out? You know, some people have thought of blowing on it, but then when you touch it, right, obviously your finger's gonna get wet. So let's talk about how we're gonna do this with the materials we have. Okay, I need a little bit more water. Let's do a little bit more water here. There we go, so it's covered. There we go, very nice. Okay, so what we're gonna do is go ahead and put your candle near the middle of your glass. Okay, next thing you're gonna do, go ahead and light your candle. There we go. All right, next step, go ahead and take your glass, turn it upside down. All right, so upside down, right side up, upside down. Hold your upside down glass over the candle and hold it for about as long as it takes for you to sing your ABCs at a relatively slow pace. You know, you don't zoom through it, but just A, B, C, D, E, F, G, like that. Okay, once you've done that, what we're going to do then is you're just going to put the glass over the candle like that, and then watch magically as the water comes up the glass. Look at that. I don't usually do this with mason jars, but now the penny is pretty dry, and all I have to do is take the penny out. That's it. I'll show you one more time. It's a fun trick to do. Okay. Let it splash out, put my penny back in there, get it nice and wet. All right, so let's go ahead and light the candle and make sure the water's out, and then just hold my glass over the candle. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z, and then put your glass over the candle right now and watch the water go up the jar. Not bad, huh? I just made that up. And there you go, all the water gets sucked up or gets pushed actually up into the glass. All right. I did promise some of you that did see this, I'm going to try and do a big experiment of it. So I'm not going to do this with the penny. I just proved that we're going to do it. I'll explain the science in a minute. I'm actually going to put more water here, and I'm going to see how much water I can put. Not that much. It's a lot of water. I'm going to kind of fill it up. Now, obviously, I know there is a limit, which you guys probably saw. There's a limit to how much water this will get pushed into the glass. So what we need is we need a bigger glass. We need a bigger glass. So here's the difference. Here's my little mason jar, and here's my 1 liter drinking cup. I know it's 1 liter just because I know it's 1 liter. We're gonna go ahead and light our candles, and we're gonna see how well we can get this to work. I'm actually gonna put a couple more candles. The amount of candles doesn't really necessarily matter. All it's gonna do is just heat up the air faster. That's really gonna, I mean, that's really it. So, and that's a hint right there, heating up the air. Okay. There we go. And then same principle, I'm gonna hold my liter glass over, and it's gonna take probably a little bit longer for the air to heat up because there's more air in this 1 liter glass than in my little mason jar. But you can actually, I can see it. I can see the glass starting to fog up. Take a little bit longer. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, and then let's go ahead and put it over, and let's see how much water gets drawn up. Now, it would be a lot more, I think, if, ooh, look at that. If the candles would float a little better, but not bad, look at that. I mean, that sucked up a lot of water. That's pretty good. So I didn't get all of it out. I think I would need a much larger glass to get this much water out, but check it out. I let go. And I just made a big mess. It's pretty awesome. All right, cool. Let's go ahead and get this cleaned up, and then I will tell you guys what's going on. All right, 4th graders, let's talk about what's going on in our science experiment. So when we put the water on the plate, put the penny there. When we put the candle in there, we lit the candle. Obviously the candle is hot, fire is hot. Fire needs 3 things to burn. The fire triangle. Here's a picture of the fire triangle. We need oxygen, fuel, and heat. So when we put the glass over the candle heats up the air inside the jar. When we put, and at the same time, it's not only heating up the air, it's also burning oxygen. So when we put the jar over the plate, there's only so much oxygen that is trapped inside the jar. So once all the oxygen is burned or depleted and it's turned into carbon dioxide, what happens, number 1, is it takes twice as much oxygen to make, so it basically takes 2 oxygens to make 1 carbon dioxide, if that makes sense. So what happens is there's less air inside the jar. Now the air doesn't, or the water doesn't rise immediately. This is because there's a temperature difference. So we heated up the air. Hot air expands, hot air takes up more space. But when the air cools, because the candle goes out, what happens then is the air contracts and you're left with less air inside the jar. So, because things like to be in balance, right, equilibrium balance, the water gets drawn up or pushed up into the jar. And it stays there because 1, the pressure stays the same, right? The pressure is now equalized. But 2, right, there is a little bit of a seam, right? So it's not a perfect tight seal, but we also have a little bit of water tension. Water is very strong, like water bonds are very strong. You've seen water bugs walk across. So there's enough pressure and also water tension at the bottom of the jar helps keep the water there until you lift up the jar. So hey, that was our 4th grade. 2 things going on, a chemical reaction, right, burning oxygen, and then we have a physical reaction, right, with the water being pushed up to make up for the difference in pressure. Yeah, 4th grade, I hope you enjoyed this. Let me know how it went, and remember, this one is just for you guys, 4th grade. See you guys later.